Welcome to our reference angles in radians lesson video. Today we're going to be talking about the reference angles for pi over 3 radians and pi over 6 radians. And so we're going to go over that and talk about what angles those actually are and how they relate and some helpful ways to kind of memorize them and stuff like that. All right, so the first thing we need to know is that whenever we see a denominator of 3 in a simplified radian expression, so for example, pi over 3 radians, it is a reference angle of 60 degrees. So the denominator over 3 means a 60-degree reference angle. All right, so this is our kind of unit circle right here. We start at 0 degrees, go around in a full circle. 0 degrees is 0 radians, 90 degrees is pi over 2, 180 is pi, 270 is 3/2 of pi, and 360 is 2 pi. So that's just kind of the quarter marks. Let's talk about all of these 60-degree reference angles. We're going to fill this in real quick. First things first, let's go ahead and fill in all the degrees. So our 60-degree reference angles in quadrant 1 would be 60 degrees. In quadrant 2, 180 minus 60 is 120 degrees. In quadrant 3, 180 plus 60 is 240 degrees. And in quadrant 4, 360 minus 60 is 300 degrees. All right, so those are our 60-degree reference angles. Let's talk about the radian measures that go along with them. So all of our radian measures here are going to have a denominator of 3. So first of all, 60 degrees we said was pi over 3. So that's 1/3 of pi. The next one along the line is going to be 2/3 of pi. So in quadrant 2, this is 2 pi over 3. 3/3 of pi, so 3 over 3 is 1. That's just 180 degrees. So the next one along is 4/3 of pi, or 4 pi over 3. 4 pi over 3. And then our last over 3 would be 5 pi over 3. Now, these are our least positive ones. These are the ones from 0 to 2 pi or 0 to 360. So these are the most common ones you're going to look for. If you get one that's more than 5 pi over 3, you're going to subtract to get back to it. Or if you get one in the negative, you're going to add to get back to it. So one thing we should know is how to add or subtract. Well, what we know is a whole circle is 2 pi. So we're going to add 2 pi rather than adding 360 like we do with degrees. We're going to add 2 pi in radians. Well, the problem is this is a fraction of a denominator of 3. And right now we have 2 pi over 1. So we need to change this into something with a denominator of 3. So to do that, we multiply the top and bottom by 3, and we get 6 pi over 3. So for example, if I had something like let's say 11 pi over 3. What I'm going to do is I'm going to subtract 6 from the numerator over and over, right? Because 6 over 3 would be 2 pi. I'm going to subtract 6 from the numerator over and over until I get back to one of the 4 that's our least positives. So 11 minus 6, that would be 5. So we're doing minus 6 pi over 3, right? When we subtract fractions, subtract the tops, not the bottom. So 11 pi minus 6 pi is 5 pi over 3. So 11 pi over 3 is the same as 5 pi over 3. So we would use this angle because they are coterminal. All right, so let's go ahead and talk about this. A couple things that we should remember from this slide here. Denominator of 3 means 60-degree reference angle. The way I always like to think about it is this is 0 pi, this is 1 pi, and then back at 2 pi. Our first one is 1/3 more than 0/3. Our next one is 1/3 less than 3/3, which would be 1 pi, and then 1/3 more, so 4/3. And then this is 1/3 less than 2 pi, which is 6 pi over 3. So that's where we get that 5 pi over 3. That's kind of how I memorize it when I do it. Memorizing these over 3 ones is going to be really important. And if it's not one of these 4, then you're going to add or subtract chunks of 6 in the numerator until you get back to one of those 4. All right. Let's talk about pi over 6. Now, this is kind of a little interesting thing that happens. Pi over 3 was a 60-degree reference angle. Pi over 6 is a 30-degree reference angle. So there's kind of a flip thing. Denominator 3, 60. Denominator 6, 30. All right, so let's go ahead and fill in the angles first. So the angles here are 30 degrees in quadrant 1. 180 minus 30 is 150 degrees in quadrant 2. 180 plus 30 is 210 degrees in quadrant 3. And then 360 minus 30 is 330 degrees in quadrant 4. These are our degrees, our least positive reference angles of 30. So the radian measures in those same spots. So 30 degrees, we have it right up top, is pi over 6. And then I like to think about this the same way. Right here, pi, this would be 6/6, or 1 whole pi. So 1 unit less than that would be 5 pi over 6. 5 pi over 6. 1 unit more would be 7 pi over 6. And then over here, this would be 2 pi, or 360 degrees. So that's 12/6. 12 over 6 is 2. So 1 less than 12 would be 11 pi over 6. 11 pi over 6. All right, so these are the 4 that we want to kind of learn to recognize. 1/6, 5/6, 7/6, and 11/6 pi. Those are the 6 from 0 to 2 that aren't simplifiable. And what I mean by that, for example, is if you had something like 3/6, that would simplify to be 1/2. So we don't really worry about that one. It's not a denominator of 6 because it can simplify. If you have something outside of this 0 to 2 pi range, this time you're not going to add and subtract chunks of 6. You're going to add and subtract something different. So 2 pi, remember, 2 pi over 1. If we want to find something coterminal, we would multiply the top and bottom by 6 to make that denominator 6 now. So times 6 on bottom would be 6, times 6 on top would be 12 pi over 6. We're going to add and subtract chunks of 12 to the numerator and denominator. So let's make up another one. Let's go ahead and say 25 pi over 6. All right, so I'm going to go ahead and add and subtract chunks of 12. So if 25 minus 12 pi over 6, that would get me to 13 pi over 6. 13 pi over 6 is still too big, so our biggest here was 11. So I would subtract another chunk of 12 pi over 6. 25 minus 12 minus 12, so that's minus 24, would leave us with just 1 pi over 6, which is in our least positive circle here. So a 25 pi over 6 angle is it's a 30-degree reference angle, but it's the same as a just straight up 30-degree angle in quadrant 1. So this is how you're going to figure out these bigger radians. All right, let's go ahead and do a handful of practice problems here. So remember, when we see the denominator, we can figure out what the reference angle is, and we can try and figure out what quadrant we're in using some of those clues I talked about. And then if it's something that's outside of a 0 to 2 pi range, we can add or subtract different chunks of 6 for a denominator of 3, or 12 for a denominator of 6 to get us back there. All right, so first things first, we're just going to draw an angle for each of these. Every time I do one of these problems, I'm going to try and draw an angle. Let's see, 5 pi over 6. Okay, so 5/6 is a little bit less than 1. All right, so 5/6 is just like 1 bit less than 1. So that's telling me we're going to be somewhere in quadrant 2. Okay, because 6/6 would be right here at 180, or pi radians. So 5/6 is just a little bit less than 6/6, so it's somewhere here in quadrant 2. What do we know about a denominator of 6? A denominator of 6 means we have a 30-degree reference angle. If it's a 30-degree reference angle, then my opposite side is 1. Since we went to the left, my adjacent side is negative root 3, and my hypotenuse is 2. This is asking us for the sine. Since it's asking us for the sine is our opposite over hypotenuse, which would be 1/2. All right, see, look, no need to convert. We were able to figure this out just based on some contextual clues. All right, the next one, this one's 5 on top as well, but now the denominator is a little bit different. The denominator's 3. Okay, so when I see this, I think, hey, 6/3 is 2 pi would be right here. So 5/3 is just a little bit less. So we're drawing our angle in quadrant 4. All right, so 5/3 is in quadrant 4. Denominator of 3 means a 60-degree reference angle, which means my opposite side is negative root 3. My adjacent side here is positive 1 because we're going to the right. The negative root 3 is because we're going down. The hypotenuse was 2. And then the tangent here, the tangent is my opposite over my adjacent, so that's going to be negative root 3 over 1, which is just negative root 3. All right, now my final one. My final one, I run into a bit of an issue. Negative 7 pi over 6 is not from 0 to 2 pi. It's not within that first chunk. So what I'm going to do is I'm going to add something to the numerator, right? I'm going to add double the denominator. So I'm going to add 12 pi to the numerator. 12 pi plus that negative 7 pi is going to leave me with the cosine of 5 pi over 6 as a coterminal angle. So negative 7 pi over 6 isn't one of the ones we know, but 5 pi over 6, that is one we know. We actually used it on the first problem on the far left. It's over here in quadrant 2. It's a 30-degree reference angle, and we know those are coterminal. So negative 7 pi over 6 is just taking the opposite way around to get there. Positive 5 pi gets us to the same spot. Okay, so our opposite side for a 30-degree reference angle is 1. Our adjacent side is root 3, but we went to the left, so we'll make that negative. Our hypotenuse is 2. So our cosine here is adjacent over hypotenuse. That's negative root 3 over 2, which is negative root 3 over 2. It doesn't simplify at all. All right. Now, really the best way to practice this is the drill and kill, and that's what our homework's going to look like this week. It's a lot of problems. It looks like a lot, but they're pretty quick. I did these all here in about 3 minutes, about a minute per problem, but you're really going to drill these things into your head, and that's the best way to do it. I think setting them up just like I did here is a great way to get started. Eventually you'll get faster and be able to do these more in your head, but this is a great way to show your work. We'll talk about this more in our class, our live session, and I'll see you there. If you have any questions in the meantime, please reach out to me, and until then, I hope you have a great day.